is over a constant rate of change. But before we continue with that lesson, or start that lesson, let's talk about what we learned about the last lesson about conversion between units from customary to metric or metric to customary. In America, we use customary. If you go to any other country in the world, pretty much they use the metric system. Cassandra used 3 pounds of ground beef in a recipe for hamburger casserole. That's in America. However, as you go to Canada, she goes to England, she goes somewhere, Hong Kong, about how many kilograms is the mass of the ground beef? So, if you look at your metric and customary conversion chart, it says about there are 0.45, it's like 0.4536 or 26 kilograms for every pound. But she is going to use 3 pounds to make a hamburger helper. So she built it up by 3. So 0.45 times 3, that's 15 carry to 1, that's 13. Jump 2 places. So it's about 1.35 or 1 in 35 hundredths kilograms. 1 in 35 hundredths kilograms is equivalent to 3 pounds. So there was an old woman who lived in a shoe. She had so many children she didn't know what to do. She decided to hire Peacock's babysitting service. It cost $4 for an hour, $8 for 2 hours, $12 for 3 hours of babysitting service. The old woman wants to determine if the number of hours of Peacock's babysitting service is related to the cost. Is it a same rate as when you're looking at the different hours? Does Miss Peacock and her daughter charge the same for every hour? So in 1 hour working, she charges $4. That's pretty cheap if you think about it. In 2 hours, $8. 3 hours, $12. 4 hours, $16. 5 hours, $20. Let's graph this. This is the X, this is the Y. When you have a table, remember when we learn how to graph ratios, this is the X, this is the Y. So it's hours, number of hours, cost. So let's label our graph. These are the number of hours, and this is the cost. In science, you learn something called try-mix. This is the dependent, this is the independent variable. The cost depends on the number of hours you work. So the more hours you work, or more hours you babysit, the more cost it goes up. The less hours they babysit, then the less cost it will be. So the cost depends on the number of hours. So it's hours and number of hours as X, Y is cost. So 1 hour is $4. 2 hours is $8. 3 hours is $12. 4 hours is $16. So 5 hours is $20. So is this line moving at a constant rate? That means, is it moving the same amount for every hour? A fixed amount. So let's pick any two ordered pair for the graph. I'll pick this one. 2, 8, and I'll pick 3, 12. So 2, 8, 3, 12. That means 2 hours of working costs $8. 3 hours of working costs $12. By how much does the Y change? It changed by 4. How much does the X change? It changed by what? The first two ordered pairs on the graph are 1, 4, and 2, 8. We use 2, 8, and 3, 12. You can determine the rate of change by writing the ratio of the change in Y to the change in X as this. So how much did it change? Change of Y, change of X. It changed by 4. This change, how much did the X change by? Changed by 1. So determine the rate of change in the graph. It changes $4 per hour. So the rate of change is every hour it goes up $4. Changes. So let's look at the graph. Is it really true? Is it going up $4 for every hour? $4 for every hour. $4 for every hour. $4 for every hour. $4 for every hour. So this is a constant rate of change because every hour it goes up $4. So what does it mean in word form? Mrs. Peacock charges a constant rate of $4 per hour. Miss Meyer, on the other hand, charges $12 for 2 hours, $18 for 3 hours. What is the constant rate of change for cost per hour. So cost per hour. So how much does the cost change? It was 18 to 12. And how many hours changed? From 3 to 2. So 18 minus 12 is 6. 3 minus 2 is 1. So how do you read this? What does 6-1 mean? 6 is the cost. 1 means the hour. So Meijer charges a constant rate of $6 per 1 hour, or for each hour, or per hour. So it is a fixed amount. No matter every hour that you hire Miss Meijer, she'll charge you $6, no matter how many hours. So if it's 5 hours and charges $6 for each hour, it's $30. So it's $6 per hour. Who should the old woman choose? I would choose Miss Peacock because that is $4 per hour. Meijer charges $6 per hour. So a rate of change is a rate that describes how one quantity changes in relation to the other quantity. So it's change of y, change of x. If the rate of change is the same for several quantities, it's called constant rate change. That means it's a fixed amount. It's going up or down, increasing or decreasing the same exact fixed amount. So let's try one. This is the person who's driving, and this is how many miles they drove. Label the axis. This is x, this is y. So the x-axis, these represent the hours. This represents the miles. Let's move this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, it's okay. We could go up to, if you want to stick a 12. We should have done a 2, 4, 6, 8, 10, 12, maybe. So I'm going to erase that. And I'm going to make it interval go by 2's. 2, 4, 6, 8, 10, 12. And then what should I make this? I'm going to make it, I don't know, going up by 150s. 300, 450, 600. So let's see, in 3 hours of driving, you travel 150 miles. In 6 hours, we travel 300 miles. In 9 hours, it travels 450 miles. In 12 hours, it travels 600 miles. So, is it a rate of change? Is it constant? Is it going up? For every hour, is it going up the same amount? A fixed amount. What is the constant rate of change for miles per hour? So how is it changing? The miles change from 150 to 300. So in other words, it changed by 150 miles. The hour changed from 3 to 6 hours. From 6 minus 3, that's 3 hours. So 150 miles in 3 hours. Can I simplify that? I can break it down by 50 and get 3 over 1. Or sorry, 30 over 1. Stop. I can simplify that to breaking it down by 3's. Because 3 divided by 3 is 1. 150 divided by 3 is 30. Stop. I'm not sure what's with my math today. 3 divided by 3 is 1. 150 divided by 3 is 50. So what does 50 over 1 mean? What does that rate mean? I don't understand. 50 is the miles, 1 is the hour. So what does that mean in word form? The car travels at a constant rate of, 50 miles per hour. That means for every hour, it drives 50 miles. No matter how many miles or how many hours, no matter how many hour it's driving, it will drive 50 miles. It's a fixed amount. That's why it's a constant change, a constant rate of change. So, in 1 hour, it drives 50. 2 hours, drive another 50, 100 miles. 3 hours, 150 miles. 4 hours, 200 miles. 5 hours, 250 miles. 6 hours, 300. So it's a constant rate. It is going up, increasing 50 miles per hour. This is another graph. This graph shows renting movies, the number of movies to the cost. So determine the constant rate of change for cost per movie. They want you to create a table. Pick 3 ordered pairs from the graph, label. So the x-axis is the number of movies. The y-axis is the cost. So if you rent 1 movie, it will cost you $5. 2 movies, it will cost you $10. 3 movies, $15. So what is the constant rate of change for cost per movie? So let's see, how much is it changing? It changed from 10 to 5. That's changes of 5, the cost. And the number of movies from 2 minus 1 is 1 movie. So what is 5 over 1? What does this rate mean? Cost movie. To rent a movie, you will pay at a constant rate of, $5 cost per 1 movie. So every movie you rent or purchase, it will cost you $5, no matter how many movies. It's a fixed amount. Determine the constant rate of change for this one. For length in inches per month. Let's see, the months are increasing, but the length is decreasing. So how is it changing? So the constant rate of change for length and month. So the month goes from 5 to 4. But it's decreasing, 16 minus 20. It's decreasing by what? How many inches is it decreasing for every month? By 4. So 16 minus 20. Remember, add the opposite. That's negative 4 over 1. What does this mean? Length. Negative 4 inches for every month. That's in word form. Another way you could describe it, it decreases 4 inches per month. So every month it goes down 4 inches. So it's a fixed amount. It goes down 4. It goes down 4. It goes down 4. At 11 a.m., the water cooler level was 30 inches. Water, 30 inches, 11 a.m. At 5 p.m., the water level now is only at 12 inches. Ooh, it dropped. There must be a leak somewhere. Or maybe someone's drinking a lot of water right now. Determine the constant rate of change for the water level per hour. So what happened to the water level? It seems like it's going down. It was 30, now it's 12. So 12 minus 30. I'm finding the change from 12 inches to 30. And then how many hours did it time span? From 11 a.m. to 5 p.m. Let's do 11 a.m., 12, 1, 2, 3, 4, 5. 6 hours. So 12 minus 30, add the opposite. I have 12 plus negative 30. Do I have more positive or more negatives? I have more negatives by 18 over 6. So what's negative 18 divided by 6? That's negative 3 inches per hour. Yes. Or another way to say it, if you don't want to write a negative, is it going down? So it decreases 3 inches per hour. Every hour, it goes down 3, a fixed amount. So constant rate of change is showing a table or a graph or verbal. Can you find how much is it changing by for every unit? And if it's the same number of change for every unit, then it's called a fixed amount, which is a constant rate of change.